Good evening and welcome to the session number 4 from the chapter of magnetism and matter. The topic is the magnetic field on the axial line of a bar magnet. So today we will be deriving the equation for the magnitude of the magnetic field on the axial line of a bar magnet. So I have already written here, or in fact you can say that I have already derived the equation for the magnetic field at any point B on the axial line of a bar magnet. So here there is one bar magnet. This is the south pole of it and this is the north pole, and this is the geometric center of this bar magnet, and this is the axial line which I have denoted here with the help of a dotted line. So here this point P is lying on the axis of this bar magnet, and this is at a distance r from the geometric center. The magnetic length of this bar magnet is equal to 2L. Here 2L is the magnetic length of the bar magnet, and the pole strength of this bar magnet is taken as small m. Now the magnetic moment, which is denoted by the capital M, this is the product of the pole strength and the magnetic length. So this is equal to m into 2L. So now here at this point P, the magnetic field will be because of this south pole and because of this north pole. So the magnetic field due to the north pole at this point P, this is the formula which I have used. This is equal to mu naught upon 4 pi into m, where m is what? It is the pole strength, and divided by r minus l whole square, where r minus l is basically the distance between the point and the north pole. So here the distance between the geometric center and this point P is equal to r. The distance between the geometric center and the north pole will be equal to L. So the distance between the north pole and the point P will be equal to r minus L whole square, and the direction of the magnetic field will be from N to P. So that's why here I have written that is it is along NP. Now the magnetic field due to the south pole at the point P will be equal to mu naught upon 4 pi into m divided by r plus l whole square. Now here r plus l is the distance of this point P from the south pole of this magnet. So this is equal to r plus l. So and the direction of the magnetic field because of this south pole will be directed from P to N. So the net magnetic field at this point P will be equal to mu naught upon 4 pi m divided by r minus l whole square minus this value, because the magnetic field because of this north pole will be more than the magnetic field because of this south pole, and this is because this north pole is near this point P. So the net magnetic field at this point P will be equal to this value, that is mu naught upon 4 pi will be column divide in bracket m divided by r minus l whole square minus m r plus l whole square, and this will be directed from N to P. So if I solve this equation, I will be getting the value as mu naught upon 4 pi into m into 4 RL. By solving this equation, I will be getting this equation. So mu naught upon 4 pi into m into 4 RL divided by r square minus l square whole square. And if now what I have done here is I have substituted the value of this 2 ml as capital M, where capital M is the magnetic moment. So magnetic moment is equal to 2 ml. So if I substitute this value, that is 2 ml as capital M, then I will be getting this formula, that is mu naught upon 4 pi into 2 capital M into r divided by r square minus l square the whole square. So this is the exact formula, or you can say the formula for the value of the magnetic field on the axial line of a bar magnet. Now if the bar magnet is short, or you can say for a short bar magnet, the value of this R is very large in comparison to L. So in that case, the magnitude of the magnetic field on the axial line of the bar magnet will be equal to mu naught upon 4 pi. Here L can be neglected because L is very less in comparison to R. So in that case, this formula will be equal to mu naught upon 4 pi multiplied by 2m upon r cube. So thank you very much for joining this session. In the next session, we will be discussing, or we will be deriving the equation for the magnetic field on the equatorial line of the bar magnet. So till then, have a nice day. Bye.